Hello everyone, today we're going to be working on example 3-5 and this example is asking us to determine the tension in cables BA and BC, which are right here. Cable BA is this and BC right here. Necessary to support the cylinder, which is right here, with a mass of 60 kilograms. So, and a hint that we are given is that force is equal to mass times gravity, where the mass is 60 kilograms and gravity we know that is 9.81 meters over second squared. And that 1 kilogram times meters over second squared is the same as 1 Newton. So what we're trying to do is we're trying to determine the tension that is happening in these two cables to be able to support the force that this cylinder is acting on, that is acting on, like on joint B right there. So the first thing that we're going to do is we're going to find out the force that this cylinder is applying right here. So we know that the force is going to be going downwards. So as we know, as we were given the hint, force is equal to mass times gravity. So force is equal to mass, which we know is 60 kilograms, times gravity, which everybody should know, 9.81 meters over second squared. And that means that, that the force is equal to 588.6 kilograms times meters over second squared. Well, how it was mentioned earlier, kilograms times meters over second squared is the same as newtons. So basically what we have is the force is 588.6 newtons. So that is the force that is being applied to by the cylinder. So that force right there that the cylinder is applying to joint B is 588.6 newtons. Okay, now that we were able to determine the force, what we're going to do is we're going to draw a free body diagram. So a free body diagram around joint B, so that way we're able to use the method of joints to help us figure out the tension in both of the cables. So what we're going to do is we're going to draw a free body diagram to help us determine. So point B right here in the middle. And then from there, we're going to draw any forces, any reactions, anything surrounding joint B. So as you can see, we have cable BC right here. That is getting pulled away from joint B. So we have a force right here. And we're going to call that force FBC. And then we have another force right here, which we're going to call that force FAB or BA, which is called BA. So going from joint B to joint A. So FBA. And then from there, we just have a force that is acting downwards. And then from there, we know that if there was a straight line right here, like our x-axis, we know that this angle right here is 45 degrees, and that this cable, the slope is a 345 triangle. Okay, so using the things that were given to us, what we're going to do is we're going to try to find the horizontal and vertical components of these forces right here, of force FBC and FBA, because since they're to an angle, it would be easier to work with them if we knew their horizontal and vertical components, but we don't have to do anything to this force right here since it's already completely vertical. So let's start off with force FBC. So we're going to try to find its horizontal component to it. So FBC times, and we were given that this angle right here is 45. And if we were to draw a triangle right here, we know we are trying to find the tension that's going on right here. But right now we're trying to find the horizontal component of it. So we're trying to find hypotenuse and adjacent. So what we could do is we could use cosine since cosine is adjacent over hypotenuse. So FBC times cosine of 45 degrees, which is the same as, so we're going to put cosine of 45 into our calculator, and that should give us 0.7071, and then FBC. And then this force is, since it's a horizontal force, it is either acting to the right or to the left. And as you can see, this force is it's slanted towards the right. So it's 0.7071 FBC acting to the right. Now we're going to try to find force of BC, its y component or its vertical component. So we have FBC, and this time instead of using cosine, we're going to use sine, since sine is opposite over hypotenuse. So sine of 45 degrees. And if we were to put sine of 45 into our calculator, that should also give us 0.7071 FBC. And this time, since it's a vertical component, it is either acting upwards or downwards. And as you can see, FBC is going upwards. So it will have a sign of going up. Now we could try to find the horizontal and vertical components of the force BA. So FBA of X, since we're looking for its horizontal component. For here, we are given the slope, which is 3, 4, 5. So instead of having an angle, we are given the rise, the run, and the slope right here. So what we could do is we are trying to find the horizontal component right now. So we're trying to find the side of 4, and we are also trying to find the side of 5, which is why we could write this out as F of B of A times 4 over 5. And 4 over 5 is 0.8. So 0.8 times FBA. And again, since this is our horizontal, we are trying to figure out if this force is going to be acting to the right or to the left. And as you can see, this force is going slanted towards the left. So that's 0.8 of force FBA going to the left. Now we're going to try to find its vertical component. So F of B of A of Y. This time we're going to be using the side of 3 and 5. So F of B of A times 3 over 5. 3 over 5 is the same as 0.6 FBA. And as you can see, this is our vertical component, so this one is also going upwards, so that's acting upwards. So now that we found that, we are going to write out our equilibrium equations. So we're going to write that off here to the side. So we're going to assume that going to the right is positive. So the sum of all the forces in the X has to all equal 0. So we have So the first number that we're going to look at is this one right here. So these are the numbers that we're going to be looking at right now that we're writing out our equilibrium equations. So the sum of all the forces in the x direction have to equal 0. So the first one is this one right here. And we said that we assume that to the right is positive. So we're looking at this one right here. So as you can see, this force is acting to the right. So it is positive. So that's positive 0.7071 F of B of C. And then we're going to look down here for the other X component right here. And we see that this force is acting to the left, which is why it's going to be negative 0.A times F of B of A. And we know, like we mentioned earlier, that the sum has to equal 0. So that will be equal to 0. Now we're going to do our vertical components. So we're going to assume that going upwards is positive. So the sum of all the forces in the y direction have to also equal 0. So we have our 0.7071 FBC going upwards, so that's positive. Then we have our 0.6 F force F of B of A going upwards, so that's another positive. And then remember, we didn't do anything to this force acting right here because it was already vertical. But now that we found the other two vertical components, we also have to include this one. Do not forget to include any forces that were already horizontal or vertical at the beginning. Very important. So we have a force acting downwards of 588.6. So that means that to the vertical components, we're going to have a negative, since we said that that force is acting downwards, of a negative of 588.6 newtons. And then that equals 0. So that means if we were to rewrite this, we have 0.7071 F of B of C plus 0.6 F of B of A is equal to 588.6 newtons. From here, what I'm going to do is I simply like plugging in both of these equations into my calculator. The type of calculator that I like using is the TI 36X Pro. And on your calculator, if you have that, what you're going to do is you're going to click on the systems solving button. And as you can see, this is a 2x2 linear equation. So you're just going to click on that, and then you're going to enter your values right here. And then once you do that, you should get that. So if we were to rewrite this, just so you could have a better understanding, this would look something like this. Negative 0.8, and then we have 0.7071, 0.6, 0.707. And then we are trying to find F of A of B, and then we are trying to find F of B of C. And we know that this has to equal 0, and this has to equal 588.6. So we plug that into our calculator, and plugging that into our calculator, we end up finding out that F of A of B is equal to 420.4 newtons in tension, since that is positive, and F of B of C is equal to 475.7 newtons, also in tension. And just like that, we were able to find the answer to this problem right here, where it was asking us to determine the tension in cables BA and BC necessary to support the cylinder. So once again, we were able to determine that the force that was being applied because of the cylinder was 588.6 newtons. So the tension that is happening in these cables due to this cylinder is 420.4 newtons in cable BA, and in cable BC we have 475.7 newtons, also in tension.